Hey there, AP Chem Scholars. Section 3, right after Section 2, is a follow-up on the idea of rate laws. Okay, even though we're talking about it from a graphical point of view, obviously you need experimental data in order to form a graph. So this is just another way of determining the order of a reactant. There are three types of graphs you need to be familiar with. That does say three types up there. So we're going to talk about concentration versus time, the natural log of concentration versus time, or 1 over concentration versus time. Okay? And the reason why we're going to talk about three different graphs is there are three different orders that come up way more frequently, and they are the ones that you are expected to know. So they are zero order, first order, and second order. Okay? Sometimes a reactant does not affect the rate. For example, if it's a solid, it's not going to affect the rate of the reaction, so it is zero order, meaning that it really is just coming right down to the constant. Okay? When we graph concentration versus time, and we get a linear trend line, then that reaction is zero order. All right? So we graph concentration versus time. If it is a linear graph, we know it is a zero order reactant. All right, so for example, if I graph concentration versus time, here's concentration, right, square brackets, versus time, we get a linear trend line, and it will always have a negative slope. It's always going to be going down to the right. Okay, we know that it is zero order. And because of that, we also know we could find our rate law constant from the negative slope of this as well. And by slope, obviously, we're talking about change in y over change in time. That's kind of what I'm implying here. Change in concentration from some initial value to some final value over time. Okay, so the slope of a line, well, the negative slope of a line is the rate law constant. So if I know this is zero order, now I could say rate equals k, and I'd even be able to figure out the value of k from the slope. All right. What if it's not linear? Well, all right. If it's not linear, we're going to get something that is somewhat curved. So that means now we're going to go on to the next graph. So we're going to take our data, plot it again, okay? And now we're going to talk about a first order graph. So we're going to look at natural log of concentration versus time. If that graph gives us a linear trend line, then we know that this reactant is first order. Okay, so again, we plot the data and see where it lines up. So now it's natural log of concentration of A versus time. Now I get, again, a linear trend line, and it has a negative slope, which is fine. So again, we know it's first order, and K would be the negative slope again. All right, but now if I talk about what that means, now remember we were talking about natural log, so it's really natural log of the concentration, final concentration minus natural log of initial concentration over time. Okay, that's what we mean by slope. All right, so what if it's still not linear? All right, then we still have a curve, so that means that we go on again, and we make our last graph. Okay, so the last graph would be 1 over concentration versus time. If this gives us a linear trend line, we know it is second order. Okay, and I'm going to go through graphing and explain all this in a minute. However, the biggest difference is when you do this graph, you actually get a positive slope. Okay, so K now is related to the positive, or just equal to the slope of it. Okay, and that means by slope, now again, we're talking 1 over the concentration at some point minus 1 over the concentration of at an earlier point over time. So that's a little bit more complicated to work with that way. All right, but we'll come back to it. What if that is not a linear either? Well, then you made a mistake, okay? Because you only need to know 0, first, and second orders. So if you're getting something else, we made a mistake along the way. Those are the only options. All right, so let's take a look at some data and talk about this idea. So let me shift my window here a little bit so you can see what I'm seeing a little bit more. All right, so here is a set of data. Okay, we're going to graph it and see. So first, I put in my data. I'm going to go make a little graph here. We'll make it scatter. And I'll, instead of, well, yeah, we'll just go with this. Okay, well, I don't need a trend line to tell me this is not linear. I have a point up here and then going down here. Okay, it is definitely not a linear trend line. So let me modify this. So concentration versus time, we'll just say. All right. So now what I need to do, I'm going to save myself a little typing. I'm going to come over here. So we're going to get ready for our next graph. So the next graph has got to be natural log of the concentration versus time. All right, so let's see. I'm going to say equals natural log of this. And then I'm just going to drag that out. Bam. So there's my natural logs. All right, so now I'm going to go back, insert another graph. Okay. All right, so versus time. Okay, well, again, doesn't take, I don't need the trend line to see that, again, we're still reasonably curved. Okay, so that is, so it's not zero order, it's not first order. You only need to know 0, first, and second, so we could pretty much guess that it's second order at this point, but let's graph it all the same just to be safe. Okay, so now I'm going to do, I want to do 1 over concentration. Okay, so this equals 1 over the concentration. So I'm going to drag that down, do that, boom. All right, highlight, insert. Now that does look pretty reasonably linear, okay? So let me shift things over a minute because I need to get to this menu. Okay, actually I got to go this way first so you can see. All right, I'm giving you a little review of Excel. You would never obviously be doing this on a test because, well, that's not the way it works. But so we're going to go down here to more trendline options. Okay, when I do that, my side menu pops up and I'm going to go and display equation. I'm even going to throw my R squared value just to be thorough. All right, when I do that, okay, I see that my, let me zoom in a little bit. My R squared value is 0.9979, so my points are pretty good in terms of the trend line, right? A value of 1 means perfect. We're pretty good, okay? So I see my slope is 0.5645. So not only do I know the second order, I know that rate would equal K, which is 0.5645, times NO2 to the second order. So I've got that much. Now, it's possible that NO2 is not the only reactant. So this may not be the complete rate law, okay? But I can definitely say that rate equals 0.5654, right? Or no, is that 45? 45. Okay, we'll talk about the units in a second. And then we have NO2. And it should be second order, which this isn't going to let me do an exponent right now, so I'll just do it that way just to get it in there. So I know that much has to be true. Now, if there was a second reactant, I could graph that data and figure out whether that other reactant is first order, zero order, second order, whatever. Okay, and since let's assume that nitrogen dioxide is the only reactant, so that means this whole reaction is second order, which means my units here would be 1 over molar seconds. 1 over molar seconds. Okay, so there you go. That's the idea of graphically analyzing these things. Okay, let me know if you have any questions and go knock out that AP practice. Take care, guys.